Hi, today I'm going to present you the query expansion service that we developed within Work Package 1 for the CINECA project. So I want to give you a little bit of context. So we have different cohorts in CINECA. They all have data they store in their own database using their own ontology. And the goal is to make this data available through the beacon, to the beacon network. And the question is, how can we link and query this different ontology from a free text from the user? So for example, you want to find patient with cancer, how you can query all the different beacon. Some of them they will store using the recommended ontology, Gecko. And some other we just keep the data how they are and they will not map it. I mean, so it's really, how can we solve this issue? So there is a query expansion, which will, from the free text, suggest different ontology by going from an ontology to the other, which is like equivalence, or also going deeper in the subconcept of an ontology. So this is done by different query expansion. So here is the different kind of query expansion. You either have the horizontal expansion, so you have a term and you will see in which ontology similar term, a similar ontology, you can find it. So for example, in mesh, in CIT. And another expansion is the vertical expansion, where you want to go in the subconcept. A third expansion will be the data-driven expansion. Well, this one is based on a big corpora of biomedical article. You create a word unbundling model, which will then suggest some words, and it's more data-driven suggestion. And the fourth one is a variant expansion that we will see in the next video. So how we do concretely. So the different expansion I show you, we can combine them to arrive at a list at the end, to a list of ontology that you can suggest to the beacon. So you start with a free text. You could use a data-driven expansion, and this will suggest a different term based on your search term. So for example, cancer, you have tumor, glioma, carcinoma. There's a different suggestion based, so on data-driven based with the work-to-vec model. Then this one is like to suggest words for the user, but what's important then is to map it to a specific ontology. So then you can query the beacon because they need specific ontology to search for. So then we developed this API, some point where you can search in different ontology. So as you can see here, we search for cancer and we have implemented UMLS and OLS. So UMLS will search and match the exact term, so cancer, and which terminology they find with cancer. And then we group them by CUI, so same concept, and you can see for each concept there is different version, low ink. So they are all linked to CUI. So you have all this mapping you could use for horizontal expansion. And we also implemented the OLS search. So it's more encapsulated the OLS search API. So as you can see here, for cancer, we find more than 9,000 results. This is actually a very broad result. This is a ranking. So if we just display the first 100, we find this terminology. So you have Gecko, you have NCIT. So here is the result of the search. So this is our first way to map to a specific ontology. You have Mondo, Nefo. So if we come back to our search, when we match to a specific ontology, then we can expand horizontally to like synonym in other ontology. So there is this cross-reference. So for this, we have this cross-reference API. So we enter Mondo, and Mondo will return some results. So we see that we match with NCIT here. or DOID. So in we encapsulate again the ABI Ontology Lookup Service API, and so we have the reference inside ABI, which is NCIT, that correspond to ECDO, for example. So once we have expanded all of this from the first term, so we have like all the horizontal expansion. And now we can decide to go a bit deeper, because maybe the cohort will describe their data with more granularity, and not maybe malignant cancer, but maybe melanoma, leukemia, or other kind of cancer. So for this, we use a vertical expansion. The vertical expansion take as we just say in which ontology we want to expand, give the ID to expand, and then you can decide also the level of expansion. So how many children, grandchildren you want, or how many parents, grandparents you want. And then the result is there. So this is all set of expansion that could be used to be sent to the beacon to capture this more granular description. So here we are. So as you can see, by combining these different expansion, we can really suggest a lot of ontology term to the beacon. And this to make sure that we capture all the possible ontology we are describing. This can become quite huge suggestion. So we can also just reduce the number of expansion by querying the different beacon and asking which ontology is present in each beacon. There. So it was just to explain you how we can use this different API to improve the search and the recall of the search. Thank you. Bye-bye.